Hello, Todd Lewis here from Mainline Automotive Equipment, and this video is going to be about how to set up the ramp screen for doing a ramp test on the new CCS control system. This video, I'm just doing a single screen. We have the current software as of July 2025, but the head unit is not connected to an actual dyno. It's just running a head unit connected to my laptop on the desk. So we may not see valid data from things like the weather station here because I don't have a weather station connected. So disregard any weird readings you'll see regarding the weather station. So to do a ramp test, we would normally go to the ramp test screen. So we click on the ramp test tab at the top of the screen here. As the dynos are shipped, this would be a typical sort of screen you would come across when you come into the ramp screen, where this default screen I leave it in. On the top window here, we would have power and engine torque derived, and in the bottom, we'll have air fuel ratio 1 and air fuel ratio 2. This is done from a testing perspective, so as the dyno is shipped with a 2-channel CAN AFR meter, we actually test both sensors connected in the car when we're testing a dyno. So in this screen here, just to give you an outline of the screen, the plotting windows, you can go as high as 4 plots, where it gets a bit congested, so I wouldn't normally recommend that. So we'll just go to 2. Now, as in most other places in the program, you've got a gear icon where you want to change some settings. So for example, on the top window here, if I click the settings there, if I don't want to show what's called engine torque derived, I can go no channel and close the screen. So now we're just going to show power only on the top window. So we want to put torque back, we'll go back to settings. I'll click the little no channel drop down. I'll just do a search for derived, and we've got engine torque derived there. Click that. I've got a little checkbox ticked on here that says scale to first series. That means that the second channel is going to automatically scale to the first series. Now, in the case of horsepower and foot-pounds of torque, that's going to be fine. So I can leave that here. This is where you can define a scale. So if I just put 850 for the sake of it, that'll be there. This is where we can define the color for each channel when it's plotted live on the screen. And we've got some settings over here for make axis visible, where I can click on that. It'll actually put an axis you'll see between the two graphs. But to save a little bit of real estate of the screen, I generally don't have that running. You'll see here for the y-axis major divisions and minor divisions, where you can make a change that you want to see here on the y-axis. Typically, you may not have to muck around with them too much. Once again, this is as a dyno would be shipped with the default settings. So obviously here we can display up to 8 channels in either one of these graph windows. I wouldn't suggest it for a lot of channels unless you're looking at things like EGTs or multiple lambdas in some windows. But just for the sake of this screen here, I'm just going to go power and engine torque derived on the top window. There is an option of clicking what's called a reference line, where depending on what you're plotting, you may want to have a minimum and a maximum. This default number of 450 is I just have when I'm testing one of our test vehicles. I just have a line on the screen at 450 so I can see when the car's making over 450 horsepower live. So I'll just turn that off for the time being. We'll close the window down. The bottom window here, you can see here I've got air fuel ratio 1 and 2. So once again, if we click the gear icon, we can see here we've got air fuel ratio 1 and 2, and I have also got the scale to first series turned on, so they're both going to be scaled off this scale I've got here for 10 to 15. You'll see I've got a reference line set here for 12 to 13. Now, some of the data that I'm going to load into the screen will be from our test Mitsubishi Evo, so I'm just going to drop this reference line from 11 to say 12. And these are just guidelines that are shown on the screen. So you can see here down the bottom, that's just now changed that little band between 11 and 12. So when we're doing a live run, as long as our AFR traces in between that window of them two band there, then we can continue the test. It's just a guide on the screen to see what's happening as far as any data is concerned. So that sort of takes care of the two plotting windows I'm going to display here. You'll see some other blank boxes at the top of the screen here at the moment. Now these are where what will eventually be called the brag numbers will pop up there, which when we do a run will show the max numbers. And there's a setting there. Once I load some runs in, I'll actually show you more about that, what you can actually display there. But the main thing you want to do from a using the dyno perspective is the first thing you want to do is what's called configure ramp test. So if you click that configure ramp test button, it'll open up this window. And the main thing we're going to be concerned with is this little graphic at the top of the screen, where it does mimic the earlier Dynalog systems that we used to sell, where we're basically defining a start speed, an end speed, and a ramp rate or a ramp time. The big difference in the CCS software is that it's all engine speed based rather than axle speed based from a hub dyno perspective. So it makes a bit more sense to people rather than having to learn axle speed numbers. So we can see here, I've got this test set to start at 3000 engine RPM and go to 7400 engine RPM. And I've chosen a ramp rate of basically 470 engine RPM per second. And that's going to give me an equivalent time of 9.5 seconds. You can change these vice versa. So if I just wanted a 9-second test, I could change it to 9 second, press enter, and it'll automatically recalculate our ramp up time for us. So that'll be taken care of there. We do give you equivalent numbers. So if you see here, if I just put a round number here of say 500 engine RPM per second, you'll see over here on the right hand side of the screen now that the engine RPM per second acceleration rate is 500. The equivalent axle RPM per second ramp rate would be, for example, on an older Dynalog system, would have been 128 axle RPM per second. And an equivalent number on a roller dyno would be 15.7 kilometers per hour per second. This is actually kilometers per hour at the moment. We currently don't have a notification on this window here that it's kilometers per hour or mile per hour. It's coming pretty soon. So these numbers are shown over here. There is the summary of the ramp up time, the ramp down time, and the total time of the test. We also give you the equivalent actual RPM start and end speeds based off the engine numbers and based off our drive ratio, which we would by now would have technically entered as far as the vehicle setup, but I'll cover that when we get out of this screen. We do have some options in here where we can do what's called an auto arm and auto start test, where if these two checkboxes here aren't turned on, the dyno will be controlled by the spacebar, just like the earlier Dynalog stuff. So if I just close the screen down at the moment and I put it into ramp mode by hovering my mouse over that mode button down the bottom, I go to ramp test. And at the moment, if I just tap the spacebar, you'll get the traditional open throttle spacebar to start dialogue. So at this point in time, we drive up to that set point, we go full throttle, and then tap the spacebar again to do the test. So I'm going to escape out of that. So if I go back to the configure ramp test, you would generally have use these both at the same time. So now if I'm going to what's called auto arm the test. So what this will do is auto arm the test. So as long as I get within 500 engine RPM of our set point of 3000, the test becomes armed. And then to actually start the test, the system then, we're going to look at axle torque. We want to hear these default settings. We're going to look for 500 Newton meters of axle torque, and that will actually start the test. And then we'll have I've got it set here for a 2-second settling time. So before it actually starts the test. So that there, once it actually starts the test, it'll sit there for 2 seconds and then it'll actually trigger. You can have that to 0, you can have it for 10 seconds. It's up to you what you want to have there. So these options are here to use if you want to. It does fully automate the test for you, so you don't have to tap the spacebar. It is quite a handy function to use, but for the first usage of the dyno, I'd suggest just using the spacebar. But I'll turn them off for the time being. You'll notice here there's an auto stop configuration where the software will also end the test if the torque was to drop 75%. Now, typically you won't see that happen unless the car has a major drop off in torque, but you can obviously turn that on or off. I'll change the setting as you wish. The other settings here are for automatically adjust the pre-start speed. So what this does here, if I change, if I untick that, you can then manually set the pre-start and the start speed. So if I turn that on, the software will automatically set the start speed 200 engine RPM below the start speed, the pre-start speed. So that's, and I've also got a setting there for finish speed, same as start speed. So you can see here, the finish speed is the same as the start speed. If I tick that off, once again, you can define the start speed. So these two options here, once again, just allow the user to have minimal parameters they have to set up. So that's handy there. There is a setting here for where predominantly when a user wants to set up and trigger from like a trans break or something along those lines, or any particular channel they want, we can input that channel. You can, once again, you can trigger off power like we did on an older Dynlog system, but I'll probably have a more dedicated test showing that with an actual trans break connected up on the real world. So that's a bit of a summary here of this testing here. You will notice at the top of the screen, it's got linear up here. So this is, once again, this is a linear test. There is the drop down here where you can go non-linear, and I don't have anything loaded, but this non-linear test arrangement enables you to basically load a table in, or like a drive shaft curve, for example, you can put here, and you can define that up to 101 data. See here the table size, you can actually go up to 101 data points, and you can sit here and manually type one in or plot one. So if I wanted to define something, or there is also actually an option where you can, so I've just clicked there, enter. So there's now actually 101 data points that I can go through, but I'll just do a quick one just to show the example. I'll just go 5 data points just to make it simple. And I'll just put in, say, 2000, and then I'll go, for the example, we'll go 2500 at 1 second, and maybe in 2 seconds. I'm just trying to basically show a non-linear curve here, for example. I'll just go to say 2900, and then at 3 seconds I'll go up 300 RPM, so we'll go 3200, and then at 4 seconds we'll go 200, I'll go 3400, press enter. So you can see here I've just generated a bit of a small non-linear curve, and I could just keep adding data points and generate our own curve in here. What this test does enable you to do, if you want to do something completely different as far as a non-linear test, you don't have to do a non-linear looking curve. You could actually set this up and do like a step test. So you could actually step program something every 500 engine RPM, and actually have the dyno step between points rather than doing an actual curve. So it's quite flexible, this non-linear area here it is. So, but I'll just go back to a linear option for the time being and close that down. So now the test is actually ready to go. One thing you need to be aware of is the x-axis down the bottom of the screen. So if, for example, we'll go configure ramp test, and I want to start a test at, say, 2000 engine RPM, and I want to go to 8000 engine RPM. So now I've changed the test to that, but you'll notice the bottom of the screen has not changed. So you've got the option of now clicking sync x-axis, so it'll actually change the x-axis to suit what you've got defined in the ramp setup. It doesn't automatically change that bottom axis. The older Dynlog system used to do that, but this system here, you can define what you want on. You may not want to see the entire 2000 to 8000 on the screen. You might only want to see 4 to 6000. So if you wanted to, you could choose to only display a certain portion of the graph live while the whole test is done over a larger band. So that has changed theirs, but so that's an example there of defining the x-axis. But what I want to do here now is I'll just load in an existing run so we can actually see what some data looks like on the screen. So here we'll just go to the database, and I do Here we've got a mainline folder under customer. We've got our white Mitsubishi Evo, and here we've got a session we did on the 3rd of June, and we've got some run files in here. So we can also, there's a bit of a summary of they're all ramp tests. And if you hover your mouse pointer over it, you'll see a few things here. It's got set as test reference, or add to test history, or load test ramps config. So I'm just going to add a couple of these in just for the starters. I'll just actually load 6 of them in just for the sake of it. Now you notice here there's 3 different power levels. They're just basically 3 different boost settings we use when we're testing the dyno. So if I go back to dyno now. So now we've got 6 runs on the screen where we've done 3 different boost levels. Now at the moment, we can see here we may or may not want to change the scaling to make it look better, but I'll just, we'll go back to configure ramp test to see here. I'll just go back to 3000 and 7400 because that's what I did have set for these particular cars. If I was going to do the test again, I'll just go sync XAxis. It blows it up a little bit for us. You do have a maximize button in here, so you can click that and actually expand it if you want to see more detail. Now this car actually has an inherent issue that it always does when it tests on a dyno, which I'll explain that possibly or not. So I can come back to normal here. Now if you want to get rid of some of the runs, you've got like a little garbage bin option. So if I want to get rid of all of the lower boost runs and just have the 2 high boost runs there on the screen, I can do things now, like I can change the scaling here and there if I want to see more detail. You have the option in this setup at the moment, there is no filtering in this screen, and it's up to the user. You don't have to, by and large, but if you wanted to go from one extreme to the other, it would look something like that, totally smoothed. It will affect the overall numbers on the cursor a little bit if you go to maximum smoothing, but if I just go back to none. Likewise here, you can see the 2 air fuel ratio traces of that car under test. It's not the cleanest car as far as our air fuel ratio is concerned, but we can clean up that curve if we wanted to. So that's the raw data coming in from the AFR. So if I wanted to, for example, add some smoothing to them channels there, we can go to what's called setup channels. And if I just do a search for air fuel ratio, you'll notice here that there is no filtering at all on the actual air fuel ratio. The way the filtering works in the CCS, a higher number is actually less smoothing. So for example, 4 would be a middle of the range sort of filtering level. If I go back to the dyno, it's actually made a little bit of a difference there. So between 2 and 4 would be the nominal filtering we'd possibly suggest for the majority of, like at least the air fuel ratio channels. We don't tend to, depends on how much detail you want to see in the data you're looking at, for example. So if I just go back to 2, it's a bit cleaner there now. So it depends on what you're after as far as that sort of. And once again, we can maximize this up and have a look at, if you want to see it in a maximized point of view. And this screen here, so we've got I can click across the screen here. You can see the power and here on the screen and torque change. And once again, same for the air fuel ratio. So this is 2 sensors in the same sensing tube at the tailpipe. So that's why they're essentially the same numbers they are through the test. You have the option of right clicking, and you can actually, you've got like a cursor you can move around on anywhere on the tracer on the screen if you wanted to, or I can right click and disappear it. Now at the moment, the brag number shown at the top of the screen, they're basically coming from this run here. I can change it over to that run there. So that's the different brag numbers. If I go click back to that one, you can see it change there on the screen. Now, so what you show in these top windows, you can put whatever dyno channel you want there. But once again, the default config will have horsepower. But if I click the spanner icon, so we're showing power at engine speed derived, which is our mathematical ratio based off our gearing. Now, engine speed derived works fine on a manual car because there's no essentially a slip. But if it was an automatic transmission vehicle, and the first thing which new dyno users question is the RPM didn't match what the car did in the log, and that's because the dyno was looking at a mathematical engine RPM where the log would be the true engine RPM. So If we had a tacho connected to the car, and this one did, if I go tacho, we've got tacho engine speed. We'll have our brag number there. That was at engine RPM for this one over here. Now over here again, I can change that over to tacho engine speed. And it's here again, so it's pretty much the same number. So we've done it there. But alternatively, I do have other channels logged. If I put in here, just go boost, I should have boost pressure. So I had 212 kPa of boost pressure at that particular point in time. Now, an example again here now, we can change that. If I go back to channels and just type in boost, we'll make that into PSI. Do the same for boost pressure 1. So the system has lots and lots of different possibilities of boost pressures. We have boost pressure and boost pressure 1 are the two map 1 and map 2 hardwired into the system, but the user can define where all these other boost pressures come from. Now I define boost pressure 2 as my ECU boost pressure coming from an ECU, for example. And the reason why you see boost target and boost pressure ECU logger display, so because this is the CCS CAN system can communicate with multiple CAN modules, then there is a possibility that you can get CAN data from many sources. So that's why there is a lot of duplication of channels where you've got boost pressure ECU, you'll see accessory, display, and logger. So depending on what device you're connecting to, sometimes it might not be an ECU you're connecting to. For example, I would term, if you're getting data from a race pack logger, then that's the term. Sometimes if you're setting up a CAN protocol coming from a race pack logger, I would define that channel coming from a logger. So that's why you see these other different names appearing for available channels in the software. But I'll go back to our graphs, and there you can see there now we had 30 psi boost in it at 6948. So the brag numbers at the top of the screen can be any dyno channel you want, but I'll put it back to essentially the default channel we've got up there. So we've got engine torque derived, and it'll be up there at the top of the screen. So that's what we're showing there. Now you will notice at the top of the screen here we've got another window called ramp test 2. Now on at a bare minimum, any CCS system is shipped with 2 monitors, but you can go 3 or you can go 4. The system will actually take up to 8, which is, if I go window count, you can see here, technically run 8 monitors. I've never done that, but we saw plenty of dynos with 4 on the screen. But I'm just using 1 at the moment because I've just got 1 screen on a laptop displaying data. Now, but if I go to ramp test 2, you might have ramp test 2 shown on your right hand monitor, for example. So once again here, I'll set this up. So because this is our test Mitsubishi Evo, I'm going to choose a couple of things here. I'm going to put, say, boost pressure there, and I'm going to put boost pressure 2 or boost pressure 1. And I'll define a scale for that. We'll just put 45 there. I'm going to change the color of that for a live run. I'll go OK. So now you can see here we've got our boost curve on the screen. Now once again, in the case of testing the dyno, this is the 2 boost sensors effectively connected to the same point on the intake manifold. And once again, if you want some smoothing on them particular channels, you can do that. So if I go back to setup, channels, and we'll just go boost again, and we'll just add a bit of smoothing for both of these channels. Go back to there, and it's a little bit cleaner for us. So once again, we can see our peak numbers at the top of the screen. Now we might want to see something else as well here. So we'll change our plot count to 2. Now what this happens to be showing at the moment is drive ratio measured. This is this default configs I've loaded in. Because the dyno is constantly obviously controls over axle speed, and we happen to hook up a TAC lead to the car, at the moment the default dyno is actually just looking at that ratio. So for example, this car has a 4.44 drive ratio in the gearbox, so that's why it's actually shown here is pretty much a flat line of that sort of number. But you can put any channel you want in here. So I'm going to change this over now because I had some other an ECU connected. I might try and find something related to ignition timing. So I've got injection timing there. We'll try and find, we'll just go timing, see what we get. Injection timing, see what sort of terminology for different channels we got there. Go timing, see what we find. Fuel injector, ignition timing. So we've got ignition timing. We'll just click injection timing ECU and just see there'll be no data there because we don't have anything from that particular scenario. But what I'll do, I'll just find boost, for example, boost pressure 2. We'll see if we get anything there, see if I actually got it defined in this system. I'll just put a scale on. We go 0. Right, so the example here, the boost pressure 2 from this example is actually coming from the Haltech ECU via CAN into the dyno system. So I could alternatively put it at the top of the screen if I wanted to in there as well, but I've chosen to put it down here. So you do have once again, you've got a search field over here. You can type in here. If I went, say, inlet, we can see whatever comes up there. I've got inlet air temperature ECU. So you can still look at many other channels while you're in this area here. So if I'm still searching for my ignition advance or something relating to ignition. So we've got ignition angle ECU. So that's the term we need to find. So if I go back into here, we'll go ignition angle ECU. We'll go OK. So that there now we've got our timing coming in from our car when we're doing a test. Once again, if you wanted to, you can change the scales on the fly. You can click your maximize button and see what your timing curve is coming in there. So this is ramp test 2. So this would typically be visible on your right monitor. And once again, you can go up to four plots if you wanted to. So I've just got 2 here. One function that is relatively new these days is you'll have an option. You'll see here the 2 little runs we've got. If I drop down, you'll see you can write a test comment. There's an export to CSV function. So if you've done a run and you want to look at this data exported into a CSV format, you do have to go through the process of determining what channels you want to set to the export. So if you choose engine speed ECU or your whatever channels, you can actually define what channels you want to get saved in the CSV file. So if we go back to the dyno, so if I just wanted to spit that out as a CSV export, it'll do that. We can give it a name. I'll just go CSV example and go save. Now that sends out 100 Hertz CSV file, so it's very high detail. It is. So that has recently been added there. There is what's called an override drive ratio function. So if you happen to get the drive ratio wrong, you can override it there and correct the data on the screen. So all is not lost if you get the drive ratio wrong. There isn't a function here. It's grayed out at the moment. Certainly you'll notice here it says pause before opening in logger. So if I click pause logger, we have an option now in the program where rather than have to use the continuous logger, which is going for 600 seconds, it'll just show us just the actual portion of the ramp test in the logger function. So if I go to data logging now, you'll notice here we've just looked at just the short section of the run in the data logging format, and I can go here and look at a whole heap of different channels. So you can see here we've got I'm just displaying a few rotational speed channels. In this screen here, I've got some individual torques left before torque channels from the test. I've got some channels where I'm looking at acceleration, torque and power. I can go to car. So we can see here we've got an overlay of our engine speed and attack engine speed. Got some channels here. I can modify these here now and put, say, air fuel ratio 1. We'll search again for airfield ratio 2. And close that down so you can see that's it. So this part of the log is just showing us just the run file, where a normal data log will show you 600 seconds of data. So it's quite handy, this little quick section now just showing you just portions of the run that you're doing in the logger. So if I go resume logger, you see there's nothing there on the screen. We'll go back to the dyno. They're in the ramp test screen. So that'll probably do it for this video at the moment before we go too long. So thanks for watching, and we'll see you on the next one. Thank you. Bye.